Hello everyone, and welcome to Jumperman Tech, where we specialize in HVAC but do everything DIY. And today we have another service call for an LG multi-V system. Thank you to everyone tuning in to Jumperman Tech. We're working on a LG multi-V system. At the moment we're connecting our LGMV tool. We had a complaint that this unit went down with a CH35 error code indicating some sort of low pressure. The unit is currently running, which is good news. Don't see anything frozen out here, but it's a possibility. Anyways, we're just gonna look over the manual and try to see what we can find and see what the steps are for error code CH35. I'm using the LG HVAC service-business app, and with that you can check error codes. This is actually the controls for an elevator setup. Pretty cool. I'm inside here because it is freezing out there. It's like 29 degrees. So CH35 stands for excessive drop of discharge pressure. Of the compressor. So we got some sort of low pressure going on here. It says the error point. Error happens because of 10 times successive compressor off due to excessive drop of low pressure by a low pressure sensor. So it ran 10 times, it tripped on the low pressure sensor. So then they have the main reasons, and there's 9 of them, which is a lot. Number 1, we got a bad low pressure sensor. We're gonna test that in this video. Defective outdoor/indoor unit fan. You can test that as well, but you guys just saw the outdoor unit running. We could see if the indoor units are running, but I actually already know that all the indoors are running. So as far as the fans, we can leave that out of the way. Number 3, refrigerant shortage and leakage, which is so possible. So if you had a refrigerant leak, the low pressure sensor will shut you off. So we're gonna test pressures through the LGMV tool connected to our phone, and we're gonna use our own digital gauges to compare the two. And there's a couple other things we could look at as well. Then right here, deformation because of damage of refrigerant pipe. I don't think so. This installation's been here for over a decade, you know. But if you got you know, side job Sunday man over there putting on some crazy pipes for a new installation, you might have that problem. All right, it says defective indoor and outdoor unit EEV. EEV is an electronic expansion valve. Okay. Then it says 6, says covering or clogging. So the outdoor unit, something's covering it or whatever, or the indoor unit, the filter is clogged during heating mode. That is definitely a very common thing. You're gonna wanna make sure all those indoor fans are running, and you're gonna wanna make sure that all those indoor filters are clean. Number 7, it says SVC, that's your service valve clogging. Like, come on, I mean, unless it's a new installation, I think you're right. You want to make sure that those valves are open. I'll show you those as well. Okay, it says defective outdoor unit PCB. That's a little funny because there's like 8 boards, so I don't know what they mean by that. And then it says number 9, defective indoor unit pipe sensor. Defective indoor unit pipe sensor. Sure, but I don't think it will go that far because I've seen some of them actually really bad, and we don't get these codes on other units. Let's go ahead and get started. I got Christian out there connected to the LGMV. So let's see what we got. All right, so this right here is the LGMV service tool. Got it connected to the phone here. So it looks like for this one we have, at least what it shows here, says IDU 8. So there's 8 indoor units. So 1 outdoor unit, 1 ODU, and there's 8 units connected to this one. It's showing here number 2 and 3, where you see that red circle sun looking thing. That means only 2 out of the 8 are in heat mode. Then we look at EEV at 110, 135, and it says the air temperature is about 73 degrees in each room. that changed fairly quickly as far as your superheat and subcooling. Anyways, you know what we really want to do? We're gonna go to indoor unit control. I'm gonna click all, and we're gonna click heat. Then we're gonna put high fan. Then we're gonna raise the temperature inside, and we're gonna click start. And like that, I'm gonna turn all these units to heat. See, they showed some of them are off there. Let's go to monitoring. You're gonna see them slowly all turn on to heat, and I want to look at the pressures that this tool is telling us when the system is actually ramped up. So we're gonna compare the target pressure with the trace pressure, basically what it's trying to reach and what it's actually giving you, and we're going to compare that with my actual digital gauges. So like that, we're going to compare the pressures, because if you might have the wrong readings on here, your low pressure sensor could be faulty and shutting you down prematurely, and that's the whole thing here. Now we got the heat and all of them on their mode, and we're going to watch the EEVs start opening. So they all see, the whole went to 40. That means they're closed. Then they're gonna start opening up to reach the room temperature. We're gonna pay attention to the pipe in and out. Also the EEV, they said like if your EEV is all the way open, which would be at 1350, that could be an indication that you are short on refrigerant. And also you want to look at your superheat and levels. So now everything is off. I set it to 80 just now. I raised it a little. Each room, the highest, it's between 67 and 75 degrees. So they should all open. Let's give it a chance. System looks like it kind of reset itself to see what's going on. All right, let's give it a chance. I'm gonna take some screenshots along the way where you can see the EEVs. Now they're all at 90, so they all slightly opened up. And we could be watching the pipe in and pipe out temperatures to see what we got. See if we got good temperatures. Let's let this thing ramp up. Let's see what happens. But there's no error codes now, so you know, it's kind of hard to fix something that's not at the moment broken. But let's see what we can get out of this, see what kind of data we can pull. But this is kind of the steps you want to take here. All right, outdoor unit fan running, check, not the problem. As far as we know, all the indoor fans are working. Basic info, we're gonna let the target and trace, all that stuff build up. Let's take a screenshot there. Yep. Okay. Indoor unit info. The EEVs, the numbers are up, so they're opening up. So then we're gonna look at the pipe in and pipe out temperatures, see if we're getting good heat. Okay, let's pay attention to the superheat levels as well. Superheat subcooling. Pipe in, pipe out. Okay, they're all raising up. 88, 90. Let's take a screenshot there. People can see, because you can't see it too often this camera. Yeah. So all the temperatures are coming up. You want to make sure you actually get good heating. You know, so these temperatures are coming up, and those pipe in and pipe out and air temperatures are being it's being read by the indoor thermistors. They're thermistors located in the unit, so they're all coming up 95 degrees. So you're gonna be getting heat, man. Whoever's in these rooms, they're gonna get warmed up real fast. Okay, and then let's go to basic info. Look at that, low pressure target 145, but it's tracing 52. High pressure target 433, high pressure trace 300. So it's not where it needs to be, but let's give it a chance. Also, not all these units have been cleaned. So those, like, you guys seen those fan motors. I'm gonna see if I can find you guys a picture. those units are super dirty, so if that's not in a normal state, you can't really trust these pressures. You really got to get that going. But the low pressure trace is 61 and the target is 145. So it's building up, so is the high pressure. Let's take a screenshot here. So basically your targets versus trace, you're gonna wanna see what's going on with that. Superheat target 9, the trace is 19. Subcooling superheat, SCSH, target, I guess that's what it is. Target is 5, the trace is 32. SC trace, 30. Yeah, something seems a bit off here with these pressures. Look, the low pressure target at 145, low pressure trace at 40, man. Not freezing up right now. Strange, man. Let's let that thing be. But the indoor unit info, pipe in and pipe out, got some nice hot temperatures. We're already at 105 for some of them. Superheat is all but somewhere between 3 and 6, 3 and 7 degrees. But the pipe in and pipe out, we're above 100, so you got some decent temperatures. You're definitely heating. The air, I can see it's getting warmer in there. They're all set to heat. The system does run, so this is a little bit tricky. All right, so right here, take a screenshot real quick. Yep. So target was and trace for the high pressure was matched up, but the low pressure target is 145. We're only getting 31. We definitely got to check that low pressure sensor. So the trace is saying 31, so we should get our gauges on there and see what kind of pressures we have for ourselves. Look, 29, man. 29 pounds. 27 pounds. What the heck? The high pressure trace 338. I mean, high pressure target 338. High pressure trace was 357, so just about there. But the low pressure target and trace are way off. Got some freezing up going over here. Drop a comment if you guys know anything about that. But look right here. Can't really see, but right here it's frozen inside. What the heck? I'm trying to check pressure. There's ice on the floor. Got my digital probe trying to read pressure, but this thing is clogged. This thing is done. It can't even read pressure. It's frozen. Okay guys, can you see that? I know it's a little hard to see because this camera doesn't show too well, but I turned off the unit to let this thing defrost a little bit. I can see it moving in there. Slow down for a little bit. Yeah, there we go. This actually might be leaking. Oh yeah, you see that? Looks like this thing is slowly leaking. I just put some leak check on it. This over here. Boy, this stuff don't freeze. I see the slightest bubbles coming out of these. Losing a little bit of pressure. These Schrader valves should be replaced. I can tighten down the Schrader valves for now, but what I want to do is purge a little bit just to get all that leak check out of there. Wipe this down so I can get my gauges on here finally. So we're gonna connect suction right here to our suction line. Actually, we need an adapter, a 3/8 adapter. 3/8 to 1/4 inch. 3/8 to 1/4 inch. So let's hook up our gauges. Let's see what we got. All right. Got the probes hooked up over here. This is a heat recovery system, so you got 3 pipes here. Anyways, got a standing pressure. I'm gonna close up the cover. Let's start this unit up and compare it to the LGMV data. I just turned the power back on for this. If we look here, high pressure trace says 97, low pressure trace 97, and that's what my thing says. So that low pressure sensor's got to be good, man. So it's reading the right pressures. Let's let the system start and see what it shows, but it's reading the right pressures. So it's not a bad board here. Basically what you would do, you would want to check your sensor, the connection at the board, to make sure you're getting 5 volts DC. But you gotta you must be getting 5 volts DC, and the sensor actually must be good, because we're matching up here. That pressure is really low. Those Schrader valves actually leaking. I'll be interested to see if we recovered the refrigerant from here, to see how much refrigerant was put in there compared to how much we take out. Maybe we lost over there, you know. And also another thing you're going to want to make sure before any of this craziness, obviously make sure all these fans are running, outdoor and all the indoor units. It seems to be. But because those fan motors are so dirty, that can act like it's basically like the fan is not running. So they, you know, at the end of the day, it looks like it's all coming down to maintenance. It's hard to make a proper decision here between cleaning and double checking the charge here. I think that's the solution. All right, so it says suction at 56. My low pressure trace 55. So they're pretty much equalizing. Hold up. Then my head pressure over here, come on, 278. And over here, high pressure trace 272. These are fluctuating, so the high pressure and low pressure sensor are pretty accurate. Look at that suction pressure, man. This is refrigerant 410A, by the way. No, it's actually accurate. So, all right. It ain't this fan, but if you guys are watching my videos, you know what those indoor fan motors look like. They are terrible. You barely even get the heating or cooling effect in those rooms that we haven't done the full cleaning on. Yeah. It's okay. It's gonna be between two things. You could actually be low on charge, which I seen the Schrader valve leaking. I mean, that's the most common, easiest thing that makes sense. So what I would do is, we are actually doing the cleanings in the units right now in the building. They're trying to do the whole building. We've done quite a few now. So I would recommend that they pretty much do the full cleanings, then compare the data. After that, pull the charge and make sure we got the correct amount of refrigerant. And while I do that, replace those Schrader valves, even though you could use a core removal tool or even just tighten it down. But at that point, I would just change them. So those are two of the key things that I'm suspecting here. For the fact the trace and the targets don't match for the high pressure and low pressure also could mean that, you know, we are low on refrigerant. It is working though, which is interesting. It is working. All right, sensors. Also, if your discharge temperature is like really high compared to normal, they said that could also be an indication that you're low on refrigerant, but it's hard to say. I'm not exactly sure what normal would be, quote unquote normal. Nothing's normal about these units with the pressures or anything. That's crazy. But it's, I guess we could look at stuff like that. So, interesting. Electrical info. Also, they mentioned the outdoor EEV. Basically, when you turn the power on, you put your hand on it, and if it doesn't vibrate, it's bad. I mean, what a horrible instructions. You gotta call tech support for that. There's gotta be some other info. That's ridiculous. That is something I would like to check though. But yeah, the pressures, pretty weird. Also, Possibly some sort of strainer inside here got clogged up, but I will go with charge and cleanings. Regardless, the cleanings, they have to be done, and then I will come back and follow up on this, because man, this building got problems, man. This right here are your service valves, the SVC valve. So you're gonna want to make sure these are allowing refrigerant to pass. I mean, obviously that's not it here, but if it was a new installation and you happen to get into that error code, you're gonna want to make sure those are flowing refrigerant. As you can see here, the inside, you can put an Allen key inside. When it's backed out, that means it's flowing. If it's all the way in, that means it's closed, it's not flowing. So you're gonna want to make sure these three are open. I don't like the caps on these because there's no like these right here, there's no gasket inside there. I guess they work, but I don't know, I prefer a gasket. So I guess that's another thing to look at as well. I'm gonna tighten down on these Schrader valves for now until we do the follow-up here. But funny enough, this unit's been running for a few days now after they experienced that code. So while that one's real loose, so while it's working, let's let it be. Let's do the cleanings, compare data, and let's confirm that charge, because I don't trust this unit anymore. So the number one reason, defective low pressure sensor, definitely not the case. But the number two reason, defective outdoor, no, I don't think so. Slash indoor unit fan. With the condition of all those fans, man, if that's up there, that has to be addressed. That has to be, just in general, that has to be addressed. But I'm curious to see what the difference in our readings is, would be compared to after we clean it compared to now. Number three, refrigerant shortage and leakage. I mean, totally. So I got some information here, like some step-by-step stuff of what to check. I'm going to show you guys that kind of stuff. And yeah, check out the pipes. Are freezing. I mean, they're definitely freezing, but that could be caused by a number of reasons, you know, like refrigerant shortage and defective indoor fans. Just because they're spinning doesn't mean they're working. And you know, in certain times, you know, you're basically slugging liquid back up to these units, and that's why these compressors are going. It's a compressor's a vapor pump. It's pumping liquid, man. You're done, and that's why so many compressors fail here. There's so many issues. The EEV is an interesting one. The outdoor EEV. It says when you reset the power, the EEV opens and closes again. Hold the EEV in your hand and you should feel it vibrating. If it's not vibrating, it's not good. This graph would be something maybe you want to look at. But yeah, I don't like those instructions. But considering what are the top issues, yeah, that makes sense. Especially, you know, I mean, you can't look at even superheat and all that stuff, but if the refrigerant's not flowing properly, you know, it's not working right for those indoor units. We got to clean those units, seriously. It's hard to make a proper diagnosis when there's so many things out of place. You know, you want to rule a couple of things out before you make your decision. But definitely what I want to recommend them is that once again, over a year later, like, come on, we got to clean up these units. Then we're going to compare the data. Then the pressures are definitely strange. If they clear up, sure. But also those Schrader valves need to be replaced. You don't have to pull the refrigerant out if you have the special core removal tool. I have it for 1/4 inch, but I gotta guess like it's time to get one for 3/8. But I think it would be helpful here to actually pull the refrigerant Okay, pulled the refrigerant and actually confirmed charge, because there was a system here that had a leak, so that could totally happen. Another thing is they had so many issues here. I guess they had so many compressor burnouts, they put in these suction line filter dryers. Look at these things, how rusted they are. So I opened one of these up before. There's no more filter inside them, but we're getting oil trapped inside there. And you know, that's something they're gonna want to get rid of, because the way that it's piped, it goes up and like down. I don't know, I feel like that plays with the refrigerant pressures as well, and that's on the suction line. Man, who knows if they actually pulled out the cores out of all of these, because every single one of these has it, and it's kind of ridiculous. I mean, this one looks a lot better, but still, they got all these weird pipe arrangements, you know? Some really weird pipe arrangements. Might be something to get rid of too. That's gotta go. Once they're done doing that crazy job, they gotta get out of here with that. So there's a lot of things they gotta get taken care of, but yeah, cleanings, come back to read the data, make sure there's no issue with the charge. If so, leak check it, do whatever you gotta do, but we gotta take this one step at a time. That code means a lot of different things, and it is what it is, but hey, it's running and I'm out of here. If anyone found this video interesting or helpful, please drop a like, comment, and subscribe as I come out with new videos every week, and I'll catch you all next time.